All right, so this video is going to focus on how do we simplify negative square roots. So if you take a look at each one of these examples that I have on the board, every single square root that we have has a negative number underneath it. Now the significance of that, you typically are told you cannot take the square root of a negative number. It doesn't make any sense. Remember, when you take a square root, you are looking for, like for example, the square root of 25. You're looking for what number times what number. It has to be the same thing. Same number times same number is going to get that. Well, 5 times 5 is equal to 25, so the square root of 25 is a 5. So then you would then in turn think about what's the square root of a negative 25. Now your only options could be either a 5 times a 5 or a negative 5 times a negative 5, because it has to be the same number times the same number. Now if you do 5 times 5, you get 25. Negative 5 times negative 5 is also a positive 25. So it doesn't matter what you do, you get a positive 25. There is no way to get a negative 25 when you do that type of multiplication. So typically you're told, well, you can't take the square root of a negative number. So what we have in math is called an imaginary number. Now imaginary number is represented by a little I, just like this. And an I is equal to the square root of negative 1. So we've kind of just said, hey, let's get rid of that negative. Let's change it into an I, and let's keep working with the problem. So that's what the I represents. It's just the square root of a negative 1. So we're going to use that to try and simplify the following 3 examples. Taking a look at example A, so our main focus when it comes to approaching these is to work on simplifying the radical first, and then we'll see what else is going on that we can simplify. If I'm looking at this first term here, 6 times the square root of negative 9, the first thing I'm going to do is this. I'm going to rewrite this. The product rule for radicals says that I can take the square root of 9, and negative 9 is actually a negative 1 times 9. And I'm going to use that. I'm going to use the product rule for radicals, and I'm going to take negative 9, and I'm going to split it up to negative 1 times 9. Product rule for radicals says that I can do that. And the reason why I want to do that is this. When it comes to the simplifying, the square root of 9 is 3, since 3 times 3 is 9. The square root of negative 1 is an I, okay, by this rule right over here. The 6 is just going to drop down. So now what I have is 6 times I times 3. Doing a little cleanup further here, because I have a 6 times an I times a 3, I do have 2 numbers that I can now multiply together. 6 times 3 is going to give us an 18, and we drop down that I right behind it. So we're going to use that same process here to try and simplify the second term that we have in the problem. So the second term that we have there is a 7 times negative 36. So I'm going to do the same thing. I'm going to drop the 7 down, and that square root of negative 36, I'm going to split that up to the square root of negative 1 times the square root of 36. And I'm going to simplify this. Square root of 36 is equal to 6. Square root of negative 1 is I, and the 7 just drops down. Remember that this is all multiplication here, so 7 times I times 6, I can do the 7 times the 6 to get a 42, and the I just drops down behind it. Kind of think about it as your X that just kind of comes down. Leaving us with an 18I plus 42I, which means we can combine these. You can treat those I's just like any other variable. You can combine like terms. 18I plus 42I, I believe that's going to give us a 60 when we add that together, and that's going to be a 60I as our final answer. So that's how those work. Moving on to the next problem here, we have example B, where it says we have negative 3 plus square root of negative 9 squared. Now remember, when you square something, you are multiplying it to itself. So this is really negative 3 plus the square root of negative 9 times negative 3 plus the square root of negative 9. So what we're going to have to do is we're going to have to FOIL this thing. So remember, in FOIL, it is first times first. Negative 3 times negative 3 is a positive 9. Then we do outside, which is the negative 3 times the square root of negative 9, which is just negative 3 times square root of negative 9. Just like that. Slap them together, drop them down. Inside two terms is the square root of negative 9 times this negative 3, or negative 3 times the square root of negative 9, once again. And then last times last, the square root of negative 9 times the square root of negative 9. There is a rule in radicals that says the same radical times the same radical is just what's underneath that radical. So what that tells us is the square root of negative 9 times the square root of negative 9 is going to be negative 9. Doing some clean up here. So the first thing I see is that we have this 9 minus this 9. That's going to go away. We also have this negative 3 square root of negative 9, and then another minus 3 square root of negative 9. We can actually combine those all into one. As long as you have the same thing under the radical, you can add them together by adding the coefficients, keeping the radical. The way that that works, if you have minus 3 square roots of negative 9 and then another minus 3 square roots of 9, you actually have a minus 6 square roots of negative 9. Continuing to simplify this, we need to keep in mind our rule that says that we can break up the negative 9. This could be a square root of a negative 1 times the square root of a 9. And then go ahead and simplify those. Square root of 9 is equal to 3. Square root of negative 1 is equal to I. And then the negative 6 drops down. Multiplying those numbers together, negative 6 times 3 gives us negative 18I as our final answer there. Alright, so moving on to the last example that we have here. So we have negative 8 plus the square root of negative 12 over the 40. So I'm going to work on simplifying that numerator first. The negative 8 is just going to drop down. That square root of a negative 12, remember that we can break that up to the square root of a negative 1 times the square root of 12. And that's going to all be over 40. Continuing to still work in the numerators. So let's go ahead and simplify what we have here. Remember that the square root of negative 1 is an I. The square root of 12, we're going to have to do a little bit of messing around here. And let me go ahead and do it in this little section here. The square root of 12. So when we simplify radicals, remember that we need to break them down in terms of perfect squares. So there is no magic number that number times itself is going to give us 12. But what we can do here is we do know that 12 is the same thing as 4 times 3. The square root of 4 is a 2. The square root of 3 just drops down. So that's going to be what our square root of 12 over here is. It is 2 square roots of 3. And that's going to go over 40. Also, just for form's sake, the i's do tend to be treated like our variable. They do go behind the number instead of in front. So I'm just going to move that over there. Just make sure that you keep in mind that's not attached to the radical. That is 2 square roots of 3 times an I. Otherwise, the only thing we can really do here, if I'm taking a look at negative 8, 2 square roots of 3 times I, and then the 40, they are all even numbers, so we can go ahead and simplify this down. We can go ahead and divide each one of our terms by a 2 to make that negative 4 plus 2 divided by 2 is a 1. That cancels, leaving us with the square root of 3 times I over 40 divided by 2 is a 20. And that would be our final answer for that one. Otherwise, that is how you simplify negative square roots. Again, just remember that the square root of a negative 1 is I, and then follow that process with your algebra rules. Otherwise, that's it for this video.